Hey everyone, it's Mr. Anderson coming to you live with section 5.2.1. I really hope you are doing well. And as you can see here in our CPM ebook, we are in section 5.2.1 and we are going to talk today about describing a sequence. Our goal is to make sure that we can describe it both verbally and in written form, as well as mathematically using some symbolism and notation that are really going to help us communicate to others exactly what's happening, okay? As mentioned, you can find this in our CPM ebook. If you pull out the table of contents in chapter 5, you can see 5.2.1. I've got some notes put together, and I've got one problem that is really going to highlight exactly what is going on for us. And I made some modifications to some things for the purposes of this delivery, and I also have some hints on the review preview, so stay tuned at the end of the video today. I hope this one's going to be real short and sweet for you. All right, let's keep in mind our web, our equation web that we've been working with all year in this nonlinear algebra course, connecting the graph to the equation of a function, connecting the table to the situation, and then everything in between there, right? But today, the thing that we're going to use to describe the description of the sequence is problem 5-40, and problem 5-40 is set up this way. Samantha is thinking back to George and Lenny and the rabbit problem. And when she listed the number of rabbits that George and Lenny could have each month, she ended up with the ordered list below. So this is one of those situations that we had from one of our lessons in 5.1 somewhere. It was one of the options that Lenny and George had, starting with 2, and then each pair had 3 pairs of babies, if I recall the problem correctly. But here's the sequence, right? And as far as humans go, we're really good at pattern recognition, okay? So we go from 2 to 6 to 18 to 54. Now, if you remember back to the problem of Lenny and George and the rabbits, you might recall what we said was happening here. But even if you don't, ask yourself that question. How do I get from 2 to 6? How do I get from 6 to 18? How do I get to 18 from 18 to 54? And one of the things that I want you to consider is, realistically, at least this far in our mathematical careers, we have a couple of options. One of those options is to add 4. Like, I know that 2 plus 4 is 6. But does that perpetuate this pattern? Like, is 6 plus 4 18? And the answer is no. No, it is not. And that tells me that I've got to reconsider what's happening, right? That's what it says down here, and I've got a function machine descriptor for you here. She realized that she could represent the situation using a sequence generating machine, right? And it would generate the number of rabbits each month by doing something to the previous month's number of rabbits. She tested her generator by putting in a first term of 2, so starting with 2 rabbits, and then recorded each output before putting it into the next machine, okay? Below is the diagram she used to explain her idea. Okay, so here's kind of the start, right? She's starting with this 2. It's going into the sequence generating machine, and 6 is coming out. So we already said we're not adding 4. So what is the other way we could go from 2 to 6? And I think you can ponder long and hard on this, but it's not too bad to remember those multiplication facts back from 3rd, 4th, 2nd grade, wherever you got them. 2 times 3 is 6, okay? I know that. That's one of those multiplication facts that I have. And it's also pretty easy to see that if I take 6 out and I put it back into the next machine, is 6 times 3 18? And the answer is, yeah, it sure is. Okay, I'll take 18 out and put it back into the next machine and ask yourself this question, and grab a calc if you need. Is 18 times 3 54? It sure is. So that's what we're working with. We're working not with a sequence where we're adding a constant term every single time. We're working with a sequence that's multiplying by a constant term every single time. And that's what A is really asking me here. It says, what does Samantha's sequence generator seem to be doing to each input? And the answer is it, and we want to communicate this well. So use a complete sentence here if you're asked a question like this. It is multiplying by a constant term every single time. And that's what A is really asking me here. It says, what does Samantha's sequence generator seem to be doing to each input? And the answer is it, and we want to communicate this well. So use a complete sentence here if you're asked a question like this. If you're asked a question like this, by 3 each time. And that's the key. Like, you've got to remember, like, a pattern is a pattern because of repetition. So I'm multiplying by 3 every single time. It's not like I'm going to be multiplying by 3 one time and then multiplying by 4 another time. No, that's not how we're going to generate these kinds of patterns in chapter 5. Are there mathematical patterns where we see growth that way? For sure, but we're not going to see them here in chapter 5. So rest assured that you will not experience that here. Okay, let's keep on keeping on. What are the next 2 terms of Samantha's sequence? This is part B. Well, here's what I like to do. I like to go back and I like to rewrite the original. It goes 2, 6, 18, and then 54. And then they're asking us for the next 2. So I'll throw a couple blanks in there. Okay. Whenever we have a sequence, we separate those sequence entries in a list and we separate them with commas. Okay. So I'll go 2, 6. That means 2 comes first, 6 comes second, etc., etc. Okay. So I'm really asking myself, when I work on this problem, I know that I'm multiplying by 3. Remember, we said that we've got a pattern that is being fostered by the multiplication of 3. So I'm going to take here, I'm going to take here 54 and I'm going to multiply by 3. Now, do I expect you to be able to do this in your head? It'd be great if you could, but if you've got questions about it, grab that handy dandy phone calculator. All right, clear mine off. I'm going to start with 54. All right, I multiply by 3, I hit enter. Hey, 162. So I know that right here, 162 is the next term. And then I'll do the exact same process. I'm going to take it and multiply by 3 again. But what am I multiplying by 3? That 162. So I, again, go back to that calculator, 162 times 3, ta-da, 468. Could I continue this? No, I'm sorry, 486. I said 468. 486. Sorry about that. I transposed those when I was verbalizing that. Could I continue this forever? Of course I could. But they just asked me for the next 2, so I will stop right there. All right, next, part C says, Samantha decided to use the same sequence generator, but this time she started with a first term of 5. Okay? And what this is going to show us is it's going to show us that our starting value matters. Okay? So, the same sequence generator, we're going to be multiplying by 3 again, right? The same sequence generator, multiplying by 3. But the difference is we're starting with 5 and we're not starting with 2, okay? And they say, what are the next 4 terms of this new sequence? So one more time, I will start with 5, and then I will leave myself 1, 2, 3, and 4 blanks. Okay, now these first couple I think are going to be really, really manageable for me, right? I don't need the calc maybe yet. So I know that, like, see, this is going to be 5 times 3. I can do that in my head. That's going to be 15. Okay, I'm going to continue here. 15 times 3. Gosh, I can even do that in my head. At my old age, I get 45 when I do that. Now I might need to go to the calc, right? Scientific graphing, 4 function, whatever. Start with 45. I'm going to multiply by 3, 135. And I'm showing my work here. 45 times 3. Remember, on a lot of our assessments and things like that, we give you guys process points. So demonstrating you're knowledgeable of the process is really going to be helpful. One last time to get this last one, 135 times 3. I don't know what that is off the top of my head, so I've got the 135 times 3. That says 405. I'm going to trust it. 405. And there we go. We see the 2 sequences. Both of these things right here, here's my first sequence that we were dealing with. Here's the second one. Both of them had the same sequence generator. Like, we're multiplying by 3. But you can see that starting point made a pretty big difference, right? Here's the 1, 2, 3, 4, 5 first terms here. 1, 2, 3, 4, 5 first terms there. And because we started with 5 versus starting with 2, we ended up with our 5th term being significantly larger. Okay, a couple things. 541 and 543. I've got a Schoology quiz set up in your Schoology folder that's going to help you with this. Something to kind of check your learning, see how you're doing. I think if you read the directions, it's going to be pretty manageable for you. So go ahead and check that out. Your teacher may do this live with you in class. I don't know. Listen to the directions for how that is going to work, okay? But there's also a hint I'm going to drop on you for our review preview today, okay? So real quick, review preview is 44, 46, 44 to 46, and then 52 to 54, right? So skip a couple of those in the middle. And a lot of these are going to go really quick. But let me give you a hint on 44. So we're going to kind of do this one together. All right. It says in part 44, part A, it says find the slope of the line you'd get if you graphed the sequence listed below and connected the points. Okay. Well, here's what we learned from up above. Our sequence was generated using these outputs, okay? And here's kind of the thing that I've got to recall, okay? We've got these outs or outputs here that come out of the sequence, and these are going to be the ins. These are going to be our term numbers, okay? And the way to think of this, folks, it's going to be very easy to do, but you may stumble if you're not thinking of it this way. The way to think of this is think of the terms in the sequence as your y's, your output. So really what I want to do is I want to do something like this in my table, right? I'm taking that sequence now and I'm connecting it to the table. And then what's going on? Well, think back to what we did at the beginning of this video. We said we started with 5 and we put it into the sequence generator. All right. There was my start. And then I'm going to go ahead and in this particular sequence, I'm adding 3 every single time, right? I think you guys can see that from 5 to 8 is adding 3, from 8 to 11 is adding 3. After I add 3, then my first term is 8. And then after I add 3 again, my second term is 11. If I add 3 again, my third term is 14. And now I can pick any 2 terms and I can find the slope. I'm going to pick this one and this one just because I feel like it. All right? And we've got our slope, m. Oops. I picked these 2. Sorry about that. Our m, right? Slope, right? All they asked if we were to graph these and we were to connect them is going to be y2 minus y1. Right? Here's our slope formula, classic. x2 minus x1. I'm going all the way back to, chapter 2. And this can be my first coordinate, x1, y1, x2, y2, and I can just plug these things in, right? It's 14 minus 8 over 3 minus 1. 14 minus 8 is 6, 3 minus 1 is 2. The slope of this is 3. And golly gee, ladies and gents, is there anywhere that you might have guessed that might have come from, right? Was that guessable to you at all, right? The answer is I don't know. You're going to have to do a couple more of these to see if that continues, okay? Ladies and gentlemen, thanks for watching. Let me remind you what that review preview is. There you go. It is there for you. Give these things a shot, and that will just that'll just let us know what kind of questions you have. Because sometimes we don't know that we have questions until we actually have them, and the way we learn that is through trying. So, again, thanks for watching, ladies and gents. Have a great day.